All right, so I'm going to take you through the second half of this lesson, which is how we go from moles to number of particles. And then we're also going to incorporate how do we get from grams, which we learned about last time, all the way to particles. So the first thing we need to think about in order to do this is how do we go between molecules and moles? So we want to think back, what was our definition of a mole? Well, we know that 1 mole is just a science word for a particular number, and it's this number, Avogadro's number. So no matter what this blank is, if it's donuts, we have this many donuts. If it's 1 mole of pieces of paper, we have this many pieces of paper. But what we're typically going to be thinking about are moles of molecules of something. So if I have moles of water molecules, I'll have this many water molecules. So let's say, for example, we're thinking about molecules of H2O. And again, I want to be really careful with my abbreviation here. I don't want to abbreviate this as MOL because that's what moles is. So I always put molecules this way. So that means I would have 1 mole of molecules of H2O. Now, typically, we're not going to write 1 mole of molecules, right? Because that's such a mouthful. So we're going to abbreviate this and just say this is 1 mole of water. And we know that when we say 1 mole of water, we mean 1 mole of specifically water molecules. But whenever we say 1 mole of water, we mean 1 mole of water molecules. If I said 1 mole of carbon dioxide, CO2, I would mean this many molecules of CO2. So my answer here, how many molecules of water are in 1 mole of water? Well, 1 mole always means this many. So there are this many molecules of water in 1 mole of water. And so now I'm starting to see, wait a second, this kind of looks like a conversion factor because I have an equality. So 2 different ways to write the exact same value, but they have different units where one is a mole and one is molecules. So I can use this as a conversion factor to get between moles and molecules. So if I start to think about, okay, what are the conversion factors I have so far? If I want to go between grams and moles, we said we could use the molar mass because that was the mass of 1 mole of a substance. And now we have another one. If we want to go between moles and molecules, I can't read my own handwriting here. Molecules, we're going to use this value. We're going to use the definition of 1 mole. We're going to use Avogadro's number. So I've got 2 conversion factors I can use now, and eventually we're going to use them at the same time. And I'm actually going to show you one more by the end of this lesson, but let's start with these 2. So let's apply this new conversion factor between moles and molecules. So if I'm being asked, for example, how many molecules of water are there in 2.1 moles of water? Like always, I'm going to start with my given, my known. I'm always going to include my complete unit, moles of what? Water molecules, times, and then I always put my fraction bar. And then my next step is always looking at this unit and making sure that is what's going to cancel on the bottom of my fraction. It is, so I'm good. And then I say, okay, I'm trying to get from moles to molecules. Do I have a conversion factor between moles and molecules? I sure do. It's going to be Avogadro's number. I'll write that just because I keep saying it that way. It's going to be Avogadro's number. And so that's what we fill in for molecules up on the top here. 1 mole equals that many molecules. And then I get this value. So then I have another example here. It's very similar, and I just put this second example in here to show you, even if I have a different kind of molecule, so let's say instead of water, I'm looking at hydrogen, H2, no matter what molecule I have, if I have some value in moles, I can always use Avogadro's number, the 1 mole of whatever that is, in this case it's moles of H2, 1 mole of that is equal to this many molecules. So I'm using that same conversion factor, and even with the same number, my unit is just slightly different. This should also show you why it's so important to include complete units, because this is a different answer from this. These are about different molecules. So I can't just say molecules. I have to say molecules of what? So again, I use the same conversion factor here, and I end up with the same value even when I have a different molecule that I'm using. So we have one step further that we can still take this, which is, what if my question's asking me how to get to atoms? Well, how can I get between molecules and atoms? So if I want to think about that for a second, if I think about the structure of H2, for example, because that's what this one's asking me about, that is a single molecule that contains two atoms. It contains two hydrogen atoms. So in this case, one molecule equals two atoms. If instead I had, let's say, water, which is H2O, then I've got an H, an H, and an O. I've got three atoms. So in this case, one molecule equals three atoms. And I'm being a little lazy. I should say one molecule of H2O equals three atoms. And here I can't say atoms of what, because two of them are hydrogen and one of them is oxygen. One molecule of H2 equals two hydrogen atoms. So I want to add one more conversion factor to our list here, which is if I want to get between molecules and atoms, or particles more specifically, what I can use is the structure of the molecule. So I can look specifically at what is the structure of that molecule, and I can think, okay, well, that's how many atoms are in that single molecule. So I have 1/3 conversion factor I can use here, and it depends on the structure of the molecule. So putting that together, if I'm asked how many atoms are there in 2.1 moles of H2, I will always start with my given, just like I did here, draw my times and my line, and then I always make sure that my unit on top matches my unit on the bottom. And I ask, where am I trying to get to? Well, in this case, I'm trying to get to atoms, but I don't have a conversion factor specifically between moles and atoms. I don't have that. So what I have to do is I have to make a pit stop. I'm trying to get from moles to molecules, and then I can get to atoms, because I do have moles to molecules right here, and I do have molecules to atoms, so I can get from moles to molecules to atoms. So I can do a couple steps. So first, I'm going to get from moles to molecules using Avogadro's number. And then I can get, now I want these units to cancel out. I know one molecule of H2 contains two atoms of hydrogen. There should be a little 2 right here. I'll fix that on yours. So I know now all my units on top cancel with all my units on the bottom, and I end up with atoms of H. And if I throw this in the calculator, I will get 2.1 times 6.022 times 10 to the 23rd times 2, close my parentheses. I do everything on top divided by everything on the bottom. In this case, everything on the bottom is just 1. And I'm going to get 2.529, which I'm going to round to just 2.5 times 10 to the 24th atoms. But I really care more about the setup here, so that's why I didn't even include it on yours. So I really care more about the setup. And so you'll notice, just like if we were doing, let's say I was converting 7 hours and I want to go to seconds, I'm going to start with my given. I'm going to do my unit on the bottom to cancel. And then I'm going to realize, wait a second, I don't have a conversion factor to get straight to seconds. I only know how many minutes are in an hour. And I can use that, and then I can get to seconds. So we've done this. We've practiced this. So this is no different. It's just that now my conversion factors are these things I'm learning about chemistry. So my conversion factors are the molar mass, the moles to molecules definition of a mole, the structure of the atom. These are the conversion factors I can use to do this exact same kind of math. So here, instead of minutes to hours, we used our Avogadro's number. Here, instead of seconds to minutes, we use the structure of our atom. And we'll still continue to learn more conversion factors as we go through this unit, but we're always applying the same strategy of dimensional analysis. So let's do a couple practice problems. Okay, sorry, just seeing how much time I have left on my video. Let's do a couple practice problems here. So I'm going to start with this one. I always start the same way. I start with my given. I do my times, my line. I want my unit that is on top to cancel with my unit on the bottom here. And then I ask myself, where am I going? I'm going from moles to molecules. So what I'm going to do is I'm going to think back, what conversion factor do I have from moles to molecules? I have Avogadro's number. So I'm going to fill in 1 and 6.022 times 10 to the 23rd here. Now my video is going to cut off, so I'm going to hold off on filling in the answer and just make sure I get to the second one for you. So this problem looks very much like what we did up here, where we're just converting between moles and molecules. Now this one, I have multiple steps like I did when I was trying to get from hours to seconds. So I have to start with my given, same as always. Except now I realize I'm trying to get to molecules, but I actually don't have a conversion factor that'll get me straight there. So I have to go back up and think, what are the conversion factors I know? Where did I write that? Okay, so what are the conversion factors I know? I don't know how to get from grams to molecules, but I know how to get from grams to moles using the molar mass. And then I know how to get from moles to molecules. So I'm going to make a pit stop at moles. I'm going to use the molar mass first, and then I'll use Avogadro's number. So here I know 1 mole of H3N equals whatever the molar mass is of this molecule. So my molar mass is what I'm going to fill in there. Oops. And then I'll go, okay, and then I've got moles. I need to cancel moles on the bottom here. And then I can get to molecules. And this is because 1 mole always equals Avogadro's number. And that'll be my setup here. So the only thing I need to do then is fill in my molar. So my molar mass is 17.04 grams per mole. And I'm not going to show how to calculate that again here because we've seen that previously. So I'm just filling in all my values. Now I've used all my conversion factors. Molar mass gets me from grams, cancels out to get me to moles. And then this one is Avogadro's number getting me from moles to molecules. And the last piece is just going to be to throw all that in the calculator. So now I'll go ahead and throw these in the calculator since my video hasn't cut off yet, and we'll see what our answers are. 0.022 times 10 to the 23rd. So this one should come out to, it comes out to 1.8668 times 10 to the 24th. I'm going to round this up to 1.9 to have 2 sig figs. And this is going to be moles cancels with moles. This is molecules. And this one will be 29, parentheses, everything on top, divided by everything on the bottom. You should get, typo, let's see. All right, you should get 1.025, which will round to 1.0 times 10 to the 24th, and that is molecules. So that's really powerful. That allows me to say in a measurable amount of ammonia, which is what this is, I can say, I can measure out 29 grams and I can tell you exactly how many molecules there are inside that 29 grams, which is really, really powerful because we can't look at molecules. We can't look at that number, but we can figure out how many there are just by measuring it on a scale, which is really powerful, which is why this unit is so important. All right, remember you have these additional resources if you need them. They are always available